This is chapter 4. I will take you through this content. We definitely, after we collected our data through different methods, one of them is the survey. In the end, our data will be put in a rectangular format like spreadsheets, some columns, some rows, and we discussed that in the introduction chapter for how the data will be sorted. So, but as we know from other discussions, that our data are sorted in a way that we can start the analysis. We also know that we have different types of data and scales. We have two types, categorical and numerical. We discussed when it comes to categorical, we have two scales, nominal and ordinal, and we discussed the difference before. Numerical, when we have two different scales like interval and ratio. In this lecture, I'm going to focus only on categorical data that has the two different scales, nominal and ordinal, and this is the content of this lecture, especially chapter 4. But when we go to chapter 5, we're going to follow along to discuss the content of the chapter regarding how to display numerical data with its two different scales, interval and ratio. So basically, since the data being arranged in a way to be categorical data, definitely you can think of, we cannot really calculate any of the standard statistical measures like average or standard deviation. So for that reason, the only way to deal with categorical data, whether nominal or ordinal, is just to count how many times this aspect or this issue happened, and all what you need to do is to count. So that's what we call it. We put it in a frequency distribution. So maybe this is a very clear example of if we are following how many shops or how many outlets a certain retailer has. Like maybe here is an example of Loblaw. We found out in this table, it's just a frequency table by telling us that in province Newfoundland and Labrador, they have 12, while New Brunswick has 22 and Ontario has 165. So this is just tabulated or presentation in terms of table, and it's an absolute number. So sometimes we might really even represent the same data as a frequency. But as you can see, if you start to show this data in a chart, which we always recommend to present data in charts, because not always tables bringing us or giving us the visual meaning or the meaning actually based on the visual representation. So sometimes you need to be careful here. So this is the same table but in percentage. So you can see Ontario that when it had, or the previous table showed that Ontario had 165, which account for 40% of all branches that Loblaws has in Canada. They are located in Ontario. You notice as well, if you go back to previous slide, you will find that there is a category here, we call it other, where we focus only on the biggest number, like in Quebec, in Ontario, Nova Scotia, but anything else where a little bit accounted for few numbers of outlets, we put them together in one, we call it other, and this is a very good idea when you have discrepancies in scale between among different categories. So you focus on the higher one or the biggest or the larger one, and the smallest one you can lump sum together in one category and you call it whatever you want. So in this case we call them other, and they count for 9%. So this is a very important thing, and usually we want to see how can we visualize this table. So this is one of the tables that you can see, or the chart actually. We call it bar chart, and we're going to learn in this lecture that we have two types of bar chart. One it will be vertical like this, and there will be another one horizontal like that. So the top one here, it's basically here, this one is a column, and the lower one is horizontal bar. It happens in Excel, the vertical one, they call it columns, and in Excel they call the horizontal one, they call it just bar. So don't get confused when you work with software. Sometimes software, they have their own names and terminologies. So just that we have only vertical and horizontal. The question later on, when horizontal is better than vertical and the vice versa. Definitely, I can tell you a hint here. When it comes to categorical data, like the top one here. So we have here four groups. Maybe we don't know what the group are, but if the groups are nominal, like maybe kind of colors or kind of product. So if the order is not important, it's better to put it in horizontal line. But if the order is important, especially when it comes to time, so for instance, the group one represent younger customers, and group two is a little bit older and older and older. In this case, it's better to put them logically here from left to right in terms of vertical. So you have always to think um, uh, what would be the impact of the visuals that I'm using? Which one is better representation of the message that I want to convey throughout the chart, horizontal or vertical? So you have always to be aware with this. Another interesting and very popular visuals used when it comes to categorical data is what we call pie chart. And pie chart is interesting because it gives us only a complete space, which is the 100%, and then we slice the data in a way to give some colors or some size based on the size of the category. So definitely it's the best way to represent data in percentage, and it's a relative values. It's different from the bar, vertical or horizontal. But it has also disadvantage. The disadvantage of this, it happens when you have too many categories. So then the slice will be smaller and smaller. For that reason, we don't really recommend to use pie chart when you have too many categories. But it would be interesting if you have few, maybe five, or I think maximum six, then a pie chart might really help. Or nevertheless, if you go in professional life, you will find out that Py's not being used often nowadays, and they focus on the bar chart, whether vertical and horizontal is even now became popular when you sort the bars. You have to sort the bars in terms of the frequency. So that means this is what I just mentioned here. So this is kind of a representation of how, if we have just some data from wherever. So imagine here that we have a summary, because in the end, analyzing data, it means a summary. So you can see here there was like a study or a question to people coming from 5 nations, Britain, Egypt, Germany, Russia, and United States. And they have been asked questions, each one to answer, and the answer about social network, the possible answer was, or actually the possible answers in this case were no, yes, and not applicable or not available. In this case, it was about probably questions about whether here you can see data was collected on people in different countries to use social network and whether they have it available to them. So no, it means yeah, they don't use it. Yes, use it. And it means it was actually not available in this location. So you can see it's the percentage. We have two types here. One is count. Count, it means absolute value. So if you sum up all of this, which is probably will be 5,039 participants in this study, 1,249 they said no, 2,175 they said yes, and the rest 1,615 they said not available, and this number representing the relative value. And the previous table came from this contingency table. So If you go back to the early slides, you will find out that when we use the chart like bar chart, vertical or horizontal, or pie chart, we only analyze one variable. But if you want to show two variables like this, the answers and the country, so you have two variables here in your data set, then you like to summarize the data in form of what we call it summary table or frequency table. For two-dimensional, we call it contingency table. In Excel, they call it pivot table. So you can see here that basically you have some columns here, and each column represents a country, and you have rows, three of them, each one represents answer. So you can see on the bottom here, here at the bottom of each of in the last rows, you will find that this is the total. So the total Egyptian, they are 1,000, the German are 1,000, the Britain is 1,018, and so on and so forth. But also you can see here the total answer of no, the total answer of yes, the total answer of not available, and in the end you find what we call it the total. So it's a very helpful table, because from this table you can calculate what we call it probability of something to happen, or probability of a certain event. Okay, so I took the table in a different sheet in order to see all numbers here. So because it's very important to know, from contingency table like this, we can come up with more interesting results. As I mentioned in the previous slide, that this total of each column and the total of each row, because they happen at the edge of the table, whether in the last right end here or the bottom, we call them the margin of the table. For that reason, we will use this term margin later on. For instance, if I'm asking you if you want to pick up someone in random from the total 5,039, and what would be the possibility that this person is from Germany? If I ask a question like this, it means since I'm only focusing on one variable, the nation, I'm saying what is the probability that this person comes from Germany, and how many of German people in our sample we have? We have 1,000. So the answer would be 1,000 divided by 5,039. So another question, what's the possibility that this person is from Egypt? It's again 1,000 divided by 5,039. What's the probability that this person coming from Britain? Again, it's 1,018 divided by 5,039. So every time we focus only on one variable and use the margin numbers and divide by the total. Now if I say, okay, I'm not really referring to the nation, I'm going to refer only on the answer. What's the probability that this person, irrespective from which nation is coming, the possibility to say yes? So in this case, you're going to focus on the yes row and look at the total. In the end, it's 2,175. And then the possibility to find someone say yes out of the 5,039, we take this value divided by 1,539. Another one, what's the probability that this person said not available? Again, 1,615 divided by 5,039. So this is what we call margin probability. This is first one. The second thing is, what would happen if I am referring to two variables at the same time, by saying, what is the probability that this person is from Germany and said yes? From Germany, then I focus on the column of Germany. Yes, I have to focus on the row with yes. And both column and rows will intersect at the 340. Then we have 340 or 340 people from our sample are German, as well as they said yes. It's a joint here. That's why we call it joint probability. So we divide 340 divided by the total 5,039. Another example, what is the probability that this person said not available and coming from Russia. So not available, coming from Russia is 420 divided by 5039. Last point here, this again we call it joint probability. Another one we ask what's the probability that this person said no and coming from United States. No, United States, 293 divided by 5039. Now I'm going to ask the question differently. The same one here. I said here the joint is, that means no and United States happen at the same time. We call it joints, and we divide by the total sample. But what would happen if I say the person that I selected, I know that this person said no. Okay, said no. So that means now the focus, isn't it? What is the probability that this person comes from United States? So that means I gave you prior knowledge, which you know from now it's no, it's not anymore randomly. We know that you are taking from the pool of 1249 and you are asking how many of this 1249 said no, because they are coming from the United States. So it's 293 divided by 1249 and not anymore the 5039. Again, another question, the same thing. This is what we call conditionally, because I'm giving you condition. What is the probability that the person that I selected, given that this person is coming from Egypt, what's the probability that this person said yes? Okay, let's see Egypt. Then our focus now, because I know that this person comes from Egypt, then I don't anymore focus on the 5039, I focus on the 1000. What's the probability that this person said yes? Then it's only 300 out of them. So I divide 300 by 1000. This is what we call condition probability. So it's really, I hope it's not confusing. You need to, yeah, it's at the beginning it could be confusing, but once you practice, you will find very logical. Probability is all about logic and it's not about gambling. Okay, so next step is to go to, let me go to the next slide. So as you can see, the next couple of slides are really saying what I just mentioned here, so I'll not really repeat myself here. So you can go ahead and go through all these slides, because all slides are going to give you the same explanation just mentioned. So if you find, yeah, I do suggest that you go through them all. So as you mentioned, we mentioned, there are marginal probability, joint probability, and condition probability. Sometimes you might really try to present the data, especially the two-dimension, in form of charts, and this is one of the charts that you might really use it, and it's very popular as well nowadays in data visualization, and especially when it comes to categorical data. It's called stacked bar, whether it also stacked could be vertical and could be horizontal. Simpson paradox is really very interesting concept. Sometimes we need to pay attention to it. Simpson paradox results from inappropriately combining percentage of different groups. In the next table, you will see what we mean by Simpson paradox. So before I continue talking about this, I would suggest that you have a look for a couple of seconds before listening to my explanation here. So I give you a couple of seconds, but that means you stop it at your end and then you resume again. So if you did that and looked at this table and you watch very well and you ask the questions, who is better, Peter or Katerina, in terms of performance, because if you are the supervisor or you are the manager of these two people, then the next question is, if I want to give bonus or promotion for one of them, who is going to get the promotion, who is going to get the bonus? So in this case, you have to be very fair. And you give Peter and Katerina two different products. One of them is called printer paper, the other one is USB flash drive, and you ask them to sell them during a certain period of time, and then you register or you record what they did. So Peter, apparently he managed to sell 90 printer paper out of 100. That means Peter reached out to 100 clients and customer, and they managed to sell 90. Wow, this is a 90% performance. But for Katerina, she looks like even better in terms of percentage because she is now 95%. Nevertheless, if you look at the absolute number, it's totally different. She managed to sell only 19, but Peter sold 90. But if you look at the USB flash drive, you'll find different story. So still, Katrina is better. And however, if the Katrina was better in terms of percentage when it comes to printer paper as well as a USB flash drive, but overall, actually, she scored 78% because she managed to sell 94 items out of 120, while our friend Peter happened to sell 100 out of 120, which counts for 83%. If you are the manager and you look only to overall, you will probably say, okay, Peter is better. But if you look at the breakdown of everything, you will find out no, it might happen that even Katrina is better. So you have to be very careful here, because also which one is more difficult to sell, printer paper or USB flash drive? So definitely the overall is deceiving and it's not really accurate. So you have to be very careful, to be fair. Another point, it's more into art, not really science, but just to give you a hint, you need to be careful not to use 3D at all, unless the third dimension is very important for you and it conveys a totally different message. You can see two pie charts here, one left, one right, one 3D on the left, and one uh, uh, with a two-dimensional on the right. So basically, on the left-hand side is too much. It's really not the best. So I would suggest that you never use 3D like on the left-hand side, because it's really not showing what you need. But if you look at the two-dimension on the right, it gives you all information that you need. This is another one. I, I hope you see what I'm seeing here, that this 3D is not really helpful at all. It doesn't really give me any extra information. It doesn't give me the proper size of the slice, so it's really annoying. This is another one. If you have only two variables to show, why is the 3D then? So if you have two variables to show, then the best way is to keep it two-dimensional and not 3D at all. So don't do that. So basically, this is it, everyone. I hope you had yeah, clear vision of how to analyze categorical data. So have fun with it, and I would suggest that you guys to go through it before the quiz, which usually quiz number 2, that will focus on that. So on this chapter. Nevertheless, it's better you guys to always watch the model if there is any changes in the schedule, if any changes in instructions. So good luck for that.